off from the gate. Very convenient for us to deliver things and help to continue to service the community there. It is not just a warehouse. We are putting in a test dev environment. We are putting an AI lab in. We're putting conference rooms in. We're putting hoteling spaces in. This is an area that we want to cultivate the region and the people in the region to come in, meet with the vendors, meet with us, test, play, learn new things, or play with the new things to determine if it's right for you and your environment. So we're extremely excited about this. We have a tentative time frame of fall, October, November to do the grand opening of that. Obviously, depending upon construction, we know how that goes these days. We're going to also do, hopefully, long term, we will be doing integration there, full integration stacks to deliver, et cetera. So multiple.
Sorry, short term, we already have requests from Navy. So we're already hiring the next person to do imaging and validation testing.
So right in the midst of it right now, making sure that we're putting the power in, we're getting the data center set, we're getting the facilities qualified for all of those things, as well as hopefully at some point a SCIF to be able to also assist in classified environments. Okay. We do hold TS and Q depending upon who the personnel is on the team, but everyone is now is certified right now. So one capacity or the other. That is the East Tennessee region. That's what we do. Again, feel free. We'll be here all day. Please get cards, get contact information. Happy to help you guys with any mission you have. We don't just do AI. We do cyber. We do networking. We do data center. If you have a need, pretty much we fulfill it in some context. And if we can't, we will tell you we can't. We'll hand you to the best option that we are aware of in the region or nationally. This is Josh Schultz. Josh, you want to introduce yourself really quickly? And then I'll get into the.
Yeah. My name is Josh Schultz. I help out with a little bit of everything, growing our commercial side, our AI services, our logistics with the warehouse he was telling you, and then also building a lot of these collaboration centers, the actual construction and land purchase and all that. So kind of helping in growth in a number of areas, all the support people like BT that are out there trying to help and solve problems and engineer and all that stuff I'm not smart enough to do.
Josh has helped us a lot internally. Our quest for AI, our quest for the next generation. We were fortunate enough to be associated with a lot of the programs that put us ahead of the curve, as in GPU-based workloads. A lot of the programs that are working on it over at Dell and Y12, et cetera, Pantex, et cetera, give us the opportunity to play with a lot of the technologies, or at least have the request of the technologies before the general public or commercial gets involved. So over the last year, we've seen, everyone has seen the growth in it, but we've seen it on-prem. We've seen the requests of, hey, connect us federally to the cloud. We want an on-prem version. We want a cloud version. We're trying to weigh where we go and how we get there. And internally, we understood that we needed to solve that problem ourselves from a classified perspective. We had the same questions. How do we utilize this technology? How do we make sure that it's right for us? But we're secure enough so we're not having issues and we're not breaking any sort of regulations. So I think we should officially start. I was just doing an intro. I didn't mean to. So sovereign AI foundations is what we're going to go over today and what we're preaching and we're living. We believe that there is a place, obviously, for the cloud and for those resources, but sovereignty in your data is key, and having the control over it as opposed to letting others control your data. Two options right now are obviously hyperscaler led. That's where the default is going these days, and understand it. They have the infrastructure, they have the knowledge. It's very easy to get into. They have made it extremely convenient and fast and easy to get the costing model that they're using. Won't name any, but you know, they're giving out contracts of $1 for your entire organization, right? They're saying, good as much as you want. Don't even worry about it. Now, the question I have for you is, has anyone ever given you something for free? Okay? It's non-existent. And this mode is twice as bad as the past. Previously, they would give you something for free to get you hooked, to get you in, and to get you to use it some more. Microsoft is the king of this. I love Microsoft. I'm not downing them, but we all know Years ago, they fed in, hey, this is the 365. Hey, this is where you're going. Hey, this is what you need to do. Take that off premise. They got you in cheap and you will never get out. Okay. And that's fine. No one wanted to run those workloads locally anyway, generally speaking. But it was just a strategy to get you to the next payment where they could come back and say you owe us. This strategy is a little different because the data gravity shifts outward. Okay. Microsoft didn't want your data. They just wanted a payment. Problem we have now is the models, the weights, and the telemetry are now off premise. They want your data. They want your money too, but the costing model will never work. At $20 a month, they will never be able to pay for their infrastructure. We recognize that? Model never pays. So what is the value that you hold that they are taking from you if they're not charging you enough? Your models and your data. Okay? The sovereign AI has an upfront, obviously more of an upfront architecture, an upfront cost, but full control of your data, higher intent, in-house intelligence, and know how to compound. This is a key that Josh will speak to in just a little bit. And self-reliance is obviously the most important thing as well. You control not only your data, but how your models are going to predict, because as you all may have heard as well, foreign adversaries are injecting bad code into these AI models, bad data on the back end. They're feeding it incorrect data as much as they can because they want to skew the results that we will receive. This is a costing model we've been running against the standard costs across models. Okay, so HGX V300 running an open source model on-prem with a 5-year ROI. On 5 is 90 less than a penny for 1 million tokens. ChatGPT Gov, Claude Gov, and Gemini Gov give you a 1 year per use, $1 per user, extremely cheap. But they are getting your data, and this is only a federal pilot. They will be coming later for a cost. They will be coming later for money. We've spoken to them and trying to help set those contracts up. And we said, what does that forward cost look like? We need to display that to the customer. And their answer is, we don't know yet. We don't know what we're going to charge yet. Look at our commercial space. That's the deferral at this point. OpenAI, Anthropic, Google at the frontier level. List price is $25 to $6 per million tokens. You rent, obviously, it's only partial security, not totally ready. And the Ask Sage, which is your federal high-level focused SaaS model, IL5, is $45 per million tokens. So you can see very quickly how this is going to increase and cost more money as you elevate through the process. Sorry, I didn't wait on you guys.
No, you're fine. Can I add one thing?
Please.
We're already seeing the cost models changing. They start with consumers and then they're backing them in. But if you look, I believe it was a couple months ago, they started taking a lot of the features, at least Claude and Anthropic has, from the pro versions. Now it's max only. So like Claude Code now is max only because again, everybody's ripping literally hundreds of millions of tokens a week on these things that are $100 or $200 a month, and it's not feasible. And they're already, it's the beginning. They're starting to kind of phase that out. So again, it's not when it happens, it literally is starting to happen now. They're removing features entirely. They're moving a lot of things to API only. So now any harness besides Claude Code, which is a harness that is connected to any of Anthropic's models, can no longer use the login. They'll nix your account. You have to use API. So it's already going to an actual per usage because, like you said, they were giving it away, getting you hooked. Classic dealer model. From this to the entire site, this is something we put together to show you kind of the throughput of an on-prem model, right? The DGX Spark, which we have here, the Dell model today, right? There are other OEMs that have that model. Throughput is about 40 to 67 tokens per second. Monthly utility at 80% puts you at 83 to 139 million tokens per month.
You can see a drastic difference there in what the costing model would be on a per token basis in Frontier models versus what it is even just for the Spark. Now, this is the pilot. This is what we recommend when you're starting out, you're learning, you're testing individually, you're trying to run those models to perfect them. As you progress in your process, which again, he'll walk you through the life cycle of getting to the higher end. We go with the RTX 6000 model. Those can do 8,000 to 15,000 per second, 17 to 31 billion tokens. This is for small team, IDE coding. Again, something smaller that is going to be utilized by just a few people to perfect the models. You will then go to a departmental-based system, which are the GB300s. DGX stations, those are 2.5 to 8,000 tokens per second, 52 to 83 billion. Again, look at these numbers as they increase at 80% utilization. What would that cost you in a model in the cloud? Astronomical. And then eventually site-wide, you go into the HGX models, the full stack models. Those throughputs are crazy, 124 billion at a monthly in one HGX B300 with 8 GPUs in it. Those are the DGX style or HGX style boxes that you may be familiar with on a larger scale. The other thing that we hear that we want to understand is the pushback historically was, well, the Frontier models are so much better. Open source is so much slower, it's less effective. And looking, especially from a coding perspective, which is the primary use case we're going to be discussing today, multiple use cases, obviously, but just from a coding perspective, the SWE benchmark verified that if you have at least a threshold of 70%, then you're an effective model for software engineering. Okay. That's kind of the benchmark that has been across the industry that they're running the multiple models against. We looked at international models, local models, sovereign models, etc. And what we saw was that the open source models weren't quite there in 2024. That was true. But as the open source models have caught up, they are now within sometimes single digit points against the Frontier style models. And that's what's really enabling you to bring that sovereign AI on-prem with these open source models to be more cost effective. If you only have a 5% difference between the cloud version and what you're doing on-prem, is that really going to affect you that much? Because it's your hardware, it's your sovereign AI. You can just extend out the time that it takes to do so or at work. Any questions on this? The off-ramps in every step. Phase one is always governance, right? We have to do a size plan, acceptable policy, classification handling, all of the things that we need to focus on in government or even in large industry today. We want to make sure that things are secure as we start. You move into a DGX, as I said, a DGX part or RTX. For the pilot clusters, this again moves you into, okay, we planned, we're kind of learning it, we understand it's more effective for your organization. As you move up, you'll go back to departmental and then site-wide as your utilization within the corporation extends. Go back to that 1 second. Here is the ask. We want to help you get here, understand this, and get to this. That's phase one for us. If you're ready to go here, great. But what we find is that a lot of people are walking in the door and they're going, hey, I want an DGX. Why? Because I want to do AI. Okay, I'm not supposed to say this as a sales executive. I'm never supposed to say, don't buy the $700,000 machine. Buy the $5,000 machine. But that's the reality where we are. We want to make sure you're successful. We want to graduate through this system to make sure that your success is there. And that doesn't become a situation where you're going, this is too hard on-prem. We spent too much money. This isn't effective. We do need to just offload this to the cloud, right? We want to keep sovereignty and security involved, but we want to do it graduated and we want to do it effective. What we would like to see is, what do you need happening this year? What problems do you have? What do we need to solve? What do we need to come on site with you? Sit down with Josh, our team, some of the other assistants that we have, side and some others depending upon the need, and walk through that with you to find out what sort of pilot you need to push through this year. What is your biggest need? How can we help you pilot that? You want to protect your intelligence, obviously, keep it inside the fence. But the key here is accelerating your mission responsibly. We all have to do more with less on a daily basis, especially in the government space, but also in private corporations. How can you do that securely, and how can we help you escalate and elevate through that process as fast as possible? That's my single pitch. Any questions, concerns, thoughts on any of this? If not, I'll turn it over to the smart guy so he can actually show us how it works. Yeah. Perfect. Josh.
This just captures the sound and not an actual mic. Or little. Perfect. But needs to capture the early, so I apologize. All right, thanks, BT. Switch over here. Makes me happy. It's raining. So, again, my name is Josh Schultz. I don't have Brad likes to always point this out when I talk to people. I don't have the technical expertise that a lot of you have in the hardware and in the networking. I am primarily a software guy. I actually come from operating businesses for private equity. So I'm an operations guy that used software, used AI, used machine learning to streamline, predict whatever we needed to do across manufacturing, supply chain. Worked in global supply chains for a number of years. And when LLMs came out, started using them heavily and realized that they were pretty powerful, used the chat that we are all familiar with, and quickly started realizing the chat was just an engine for something bigger. About 2 years ago, started working with CTG, not the company itself, but the team at CTG, saying, where is this going and how do we start using it? The term that has come about for what we've built since, not by us, is the term harness. But it is what do you connect to the LLM to get a lot more use out of it? And so that's what I want to walk you through. Some of the things that we have figured out that we are connecting to these LLMs, how we're doing it, and how we're thinking about where it's going. Because I think it's going to change how we interact with SaaS, how we interact with the tools that we use, how we even think about what's possible. So there's going to be some theory and ideation this morning, and then we'll convert over into like actually what does it look like in code. Got Jupyter notebooks that we can run through. You can take those with you, but need to tweak the configs a little bit if you take them with you. But the goal was that we can actually walk through and see what this actually looks like. Not as complicated as sometimes it sounds, but how can we use LLMs? That said, so the first thing that was noticeable, and this really became big about maybe 9 months ago now. I keep giving this talk and the time keeps growing. The models started getting powerful enough and they changed the type of models that they were using. We'll get to that in a second. But for you that are just chatting, you probably noticed it changed. It didn't just give you an answer. It did these things and then gave you an answer. That's because the model is different. It's trained different. It does different things. And that allowed us to start actually having more power behind the engine that we were connecting to, again, things externally to chat. This will become really clear in about 4 slides. But what I want to point out is if you're just using chat, you are completely missing the real power of, and I'm going to say AI, I'm meaning LLMs today. You're really missing the power of that. And so we've spun a bunch of these up. I've got 3 of these at home that make this a much better setup. Trying to work with one this morning has been a pain, but we'll make it work. But when you start basically running this on-prem with what we're using is Ray, which is basically like a distributed computing. And then we're just going to use the Nematron model today, or the Llama model. And you start to realize that the model itself can give you answers, but the model can execute tools, which are just scripts or Python scripts. You start to basically give hands to the model. So the model's thinking, and then it can execute. And then you can control via security the actual deterministic scripts that it's running instead of trying to stop this model, there's all this work like permissioned LLMs. I don't know if you've read the academic papers, but they're trying to train it not to do bad things, but it always still does some bad things, right? It's like disciplining a kid, like it's still in there somewhere. You can't be 100% secure by affecting the model. So it's what we put over the model that really is where we start to get the security. So here's the things that have really made it so that it can be used in an actual, I believe, environment, like a use case. It was a cool chat up until about November of last year. First thing that happened is, I'll go to number 2, the open weight started catching up. So the open weight models were horrendous. I mean, basically you could make it repeat your name back to you. And if you wanted actual answers, you had to go to ChatGPT or, Anthropic, one of those frontier models. But the open source models started getting pretty good and being trained on a lot of the data. And when you niche them down and fine tune them, they're actually better than the frontier models. You can get a better coding agent or a better, provisioning agent, whatever it is you want that agent to do or that LLM to do. You can actually fine tune it using something called like unsloth or whatever, and it can get better. You can train it on your company data. You can have a very specific company brain that is answering, and it's going to be better than a frontier model. So there, like he said, there was the gap, but you can fine tune your way to the gap. You can add skills. We'll get into that. Pretty soon, you're way better than a frontier model. So now we can self-host. That's going to be really, really important later for cost, for security, and for actually tuning it how we needed to tune it. Can't tune a frontier model. The second thing that happened is harnesses matured. So we were playing with a bunch of this, and one of the things we noticed was the LLM was always smart enough to do what we wanted. It was often an organizational problem. So think about your departments where you work. You might have a lot of people that are smart enough individually to do what needs to get done. It's getting them to properly communicate, to understand the goals of the department vertically. It's what we call an organizational challenge. How do we get proper communication, task sharing, make sure we're not working on things that are going 2 different directions? All these organizational challenges were where the models, the harnesses, the agents were failing. The LLM had the information it needed, it just wasn't coordinated properly. So one of the things we started doing a while back was building organizational harnesses, which we'll touch on a little bit today, but not much. But it was, how do we get multiple agents that are fine-tuned to one specific thing to correctly pass off, to communicate back and forth, to work out problems, to store information in the right spot, to start to do the things like we want employees to do, like we want coworkers to do, like we need our departments to do, like all that organizational stuff. That's the limit, and still is, I believe, the limiting factor in how far these things can go. But Anthropic gave everybody 2 weeks free around between Christmas and New Year. Anybody an Anthropic Claude coder in here? Right. So it's a coding agent, but you really don't have to code in it. You can load any skill you want. It can do workflow. It can do Excel work. It can read and find anomalies. We've got a number of machine learning models that help us predict and find things and isolate problems just in running our business. The AI can actually start to orchestrate those. So people started building like crazy, mostly kids that had a lot of free time. And they basically spun up a lot of something called OpenClaw. Who's heard of OpenClaw? Right, scary, but it exists, and the concept, this idea, is cool. So we were looking at it saying, hey, this is basically what we've been building. Let's go borrow some of those patterns, but pull them into what we're doing, which is, we call it a trust network. It's called ARP. We'll touch it later. But the kind of the main frameworks around harnesses, and then all of the different parts of the ecosystem that can pull from those, the skill idea and all this stuff, really matured enough where there was enough of an ecosystem where you could go build around it. The third thing is, on-prem got real. If you were following Twitter or anywhere where these kids were posting, what was the big craze? Anybody know the big craze that happened right after OpenClaw? What did people still go start buying? And they're still buying.
Mac Minis.
Mac Minis. I thought it was funny that the consumer market literally started going off-prem the second that they started getting these harnesses matured. And there's a reason, because the way that AI works is it is context greedy. It wants information, it needs knowledge and intelligence, and hosting that somewhere gets very hard. You can't host it on a SaaS, can't put it in Confluence and use whatever it is, Roto or whatever their AI is, because it only knows about what's in there. You have to own it yourself. And so it became very obvious to the kid, and I like to watch the kids because they're always on the edge and you get ideas and then you got to harden them and formalize them. But I noticed they started going right to on-prem, and it made sense. Once we started using these at CTG, we immediately got 15 of these, spread them out and said, okay, we're going to start running things here. We're going to start basically having a central repository of brain our information. We don't want this getting out. This is staying on our equipment, running on our models, and now it's all self-contained. So all three of these kind of happened over the last few months and changed what was possible. And so what I want to do today is go over, and again, this is just a mental exercise of what is possible. I gave a talk like this in Vegas to an ERP convention. It was all manufacturers. And I had 3 CEOs come up and say, I keep hearing I got to use AI. I didn't get it. I thought it was a chatbot. After seeing what you showed us, I now get that I need to go do this now. I see where the industry is going now, and I want to hop on it. And so we've helped them build roadmaps and done full day sessions across the East Coast with medical manufacturers and all the different compliance that they have to deal with. So my goal was to give you all the same thing so you can mentally run through your days, departments, and start to think, okay, aside from a chat rag, not a fan of rag, maybe touch that later. But aside from that, how do we actually use AI so it's useful and we get an ROI, not just another tool that I'm managing that gives me a 10x surface security issue and create more problems than it does solve. Before I start, that's the intro. Any questions, anything I said, where I'm going to go? I can deviate too and answer questions. We can deep dive on whatever you want. I'm here so that you guys get value, not so that I can give this pitch. I've given this pitch before. I'm sick of giving it. So my goal is that you guys get something out of this. So feel free to interrupt me. I see a few familiar names that I met at Inlet out there, but feel free to stop me if you have any questions. Anything so far? Everything makes sense? Great. Going to try and stay mid-level here so we don't get too deep.
Can I interject?
Yeah, please do.
2 seconds. And I'm going to call people out here kind of individually. I'm sorry. I just want to make sure we're setting the stage on kind of where each group is right now, right? Because we have a separate group of individuals here. So just starting out, kind of where are you, Wes, in your knowledge base and in your work life? Where do you guys see yourself right now in this stages?
So for me personally, I built it's not why I get it. Basically walking through the paces, and instead of performing the function at the end of it, it was telling me what it went down. So I can get a little bit of see obviously the foundation.
Great. Thank you for that. Again, just kind of setting the stage at each person's level and where we're at. How about you all? Where are you all at right now? You think the progression individually or as a group?
We're procuring devices. I use it today. That's fine.
Very
Complete tasks. Take it to the next level.
great. And you guys use an open source right now, as you said? There, if you could say, yeah. Okay.
Yes.
Yes, there's models. Very good. How about yourself, sir? Security validation is kind of where you all are at right now. How about you?
My team is they looked at really incredible forces, something to use rapidly.
So you're in the discovery phase at this time, maybe have some projects, but you haven't really moved through to the hardware or software stage yet. Gotcha. Is there urgency behind those needs? Do you feel like organizationally they're behind you, or is this more of a discovery phase? That's good, because you don't want to be too rough on it.
She's taken the peer to support. Yeah, provide. Right there. Gotcha.
So using it analytically to proactively determine where issues may be, project, put you out to feel faster if it's a solved problem. But you, sir?
We're doing, I should be left in a lot of ways from how we're enhancing customer experience. A lot of it is also harnessing the data, make sure we're focusing and driving our business the direction that it needs to. And then helping other customers get more on the forefront of agentic AI within security and vulnerability remediation and trying to get more advanced in that space.
So from a security perspective, utilizing it for logging, algorithms, et cetera, correct?
Trying to get more
Say self-healing or self-utility?
self-healing.
Self-healing.
I'm gonna start with you and work our way to the right.
Yeah, pretty much the same thing. We're right in the middle of everything. Personally, I have a home. All of that.
Yeah.
Familiar with it helping me build a website or an app.
Yeah.
Problem I have, is exactly training the model, right? I'm not very good at that yet.
Get the data to it.
Yeah, so, it is hard.
Yeah.
And, yes, that's.
Yeah, that was a big problem I had as well. Sir?
I manage the IT company that's been around now, so we're in the stages, pretty big, the help is when you do experience.
Very nice.
I realized that I don't know quite what I know, what I don't. I thought with those CEOs, I have a grip on this. Not quite the grip I thought.
I told you that in the beginning when I walked in.
It's
I'm just saying, but
necessarily maybe and see too much, but maybe it's offering.
well, I appreciate you guys sharing that with us. Again, we want to make sure the context is correct. We're answering the questions and meeting you where you are. But give you a little. There.
Yeah, quick, who is not going to be here this afternoon? Y'all are staying the whole time? Okay. Because I'm getting, there's, Paul, right? You said something and then you both said something that I want to make sure we're covering in depth later, but I want to at least give you like where to go look to solve some of the problems. There's like different layers of how you train the model, obviously through prompting, but that doesn't do much. But there's a really specific skill approach that you can use. And then there's like, what do you bake into the model and what do you not bake into the model? You solve it with retrieval scripts or whatever. So just some architecture there. We can go in deeper offline, but I had a lot of those problems as well when I first started. And not say solved them, but got them working. And then self-healing is something that we built art for, so we can talk about that as well. What can it modify? And then security-wise, what can it modify? How do you sandbox it? So we built our own agentic loop, our run, which basically can sandbox code execution or itself and then destroys the whole thing. It's just the answer out. And then we use what we call a policy engine. So we write policies that get injected into the context every time. And again, we can look at that later and go over it. But some of those problems that how we've solved them. So, and again, I hope to live past today. So if you guys want to dive in some other time, I can just jump on a call and talk to you about it. It doesn't have to be today at the demo. These are all live demos. These are all spin up Docker containers. We're going to go into some of these later, probably not all of them, but a number of things. And we pull in APIs from the government all over that are online free. And then we've got some of our own data. So we have built all of these. These all run. Actually, this is all coming from the GB10 here. That's why it looks like a not safe IP that I haven't going to here. But yes, we run all of these locally. We build demos based on talking to different customers and what they're trying to do. We show them how it work. So this is kind of like a quick, here's how it worked. And then we go build like a production one for them. So we'll do this later, but you were asking where they're at, want to show them. We've got a number of things that we can demo for them later. Thank you. Back to this. So first thing that changed that's important is we got reasoning models. Reasoning models are not the same as the original models that we were using when ChatGPT first came out. The main difference being they're trained on reasoning traces and tool calls, not on next token, or it's still next token prediction, but it's not predicting a word phrase. Does that make sense to everyone? So what it used to do is basically keep looping and say, what's the next word, the dog, and then go back and say dog ran, and then it would go back. It would just keep doing that over and over. And that's why you got that streaming chunks of tokens being output. All the models those models still exist, but the models that are running agentic is reasoning models, and that is call this, bash, grep, look for this, now edit. So it's basically like your CLI, like you're controlling it. It was trained on a ton of those reasoning models, which tools to call, how to know what tool to call. So the first thing is we've got this new type of model, and they've gotten better and better and better. There is a data set on Hugging Face for those of you that are trying to train your own models or tune them. it has like a number, somebody took like hundreds of thousands of Claude Opus 4.6 reasoning data and basically has it in a clean data set. So you can take whatever model you have and help it get better at reasoning by running it against 4.6's reasoning traces. And again, 4.6 is one of, at the time, was the best reasoning model. Now it's doing a 4.7, and that's probably the best reasoning model. So you can really boost performance just from training on that. So we gave it a really good brain to figure out that it could go call this stuff. We said the hands and the feet, and then we actually gave it hands and feet. We started connecting it to tools, which is just a fancy term for like Python scripts. Go all the stuff we would do, regex, go pull this, look for this, replace this. We gave it about 7 different bash commands, so it can go search, it can write, it can edit, it can delete, and then we kind of sandboxed it where it can do that. So now we have a brain that can go act, and this is really what the agent is. The agent is something that can go execute on our behalf, not just give us ideas, tell us that our diet's bad, whatever it is that we were chatting with it back in 2022 when it came out. So this pattern is important for a lot of reasons. One is that these are deterministic. So a lot of the tools that you see online are literally scripts or their API calls combined with a skill that tells you how to use the API call. However, where we've been using a lot of this is in combining it with existing either mini software or machine learning. So you can have machine learning that's predictive. We got it on the demo site. We've got one where we're pulling in the grid usage right from power. And we can use something like Profit, Facebook Profit, which is a forecasting for time series. We can detect what the power should be over the next day or whatever. And then we can look at anomalies based on that prediction so that we're not just looking at the data when it's moving, but actually like a Z-score against that. And then we can have an automated report run whenever the anomaly or the Z-score is above 1 or below -1. So we're now using the agent to manage, again, all the variables, the parameters on deterministic models, even complex ones, vision ones. So do we include weekly seasonality or not? Normally we have somebody typing in all those params when they're building the Facebook model, the profit model, but now we can have AI test them all, work with it, change it in real time, use reasoning traces. We give it tools so that it can modify it and then tools so that it can run it. And basically we start to have this thing that is working with deterministic tools, making them better and better. So we still have a lot of problems though. This doesn't get us very far. We're still telling it what to do constantly, but it can go do it once it figures it out. So here's what we still have basically a chatbot that can go touch our computer at this point. What we're trying to do is get to a coworker where we can delegate tasks and then communicate as if we're communicating with a coworker and have them get done correctly, safely, efficiently. Efficient is key. We don't want to spend 5 billion tokens trying to get a simple task because our agentic loop is cruising. So we're trying to move away from chatbot, which is I get a request, I get an answer back. It's useful, but not entirely useful. We don't want dashboards. A lot of people are using agents for generative UI. There are some cool use cases there, but again, a dashboard is just telling me more information. I've had a lot of dashboards built for me. I think after 2 days, I never look at them again. I want the actual thing that's wrong. Like everything just looks correct all the time on the dashboard, right? The second you create it, everybody fixes it, and all of a sudden everything's green and you just stop looking at it. But I want our alerts, like anomalies in real time. So that's where AI is going to help us. You can build live briefings. You can have briefings triggered via anomalies. Again, Z-score is a simple one to talk about, but obviously anomaly, you can do clustering, all that stuff. So that's the coworker, right? That is spotting a problem solving it, and then either executing a solution or doing a human in the loop. Like we have a draft where it drafts up a possible phishing notice, but doesn't go execute anything until you say, yeah, distribute or approve to the SOC or whatever. But that's what we're trying to get today. This is where we are with reasoning and tools. Amnesia is first of all an issue. It's a cold start every time, right? LLMs are stateless. They don't seem it because of the way that the loop runs, but they're stateless. They know every time you hit enter, it's a brand new call with more and more of your history so it can remember all the things you just talked about. So amnesia is a huge problem. Tools we've got to add to the reasoning. And then no colleagues. We're not going to get to this one today. That would be too much, really boring for y'all probably too. But there's no colleagues to spin things. The main reason this matters is because as you use if you build the agent correctly, as I think you were alluding to, it should get better at whatever it's doing. And if you have it trying to get better at 14 things, it stays average or even subpar because the tuning is different directions. So one of the architectural decisions that you all should be thinking about are, what are the niche things that we need done for this workflow? How many actual steps are there that require a different focus, a different identity, which we'll get into later, and a different process? And then you want to create multiple agents so that they get tuned, because if you build it right, they will tune themselves over time and get better and better. But again, if you're tuning towards this vector to get better at recognizing something, and then this vector to know how to execute it correctly, it'll kind of obviously not work out correctly. You end up in the middle somewhere. So we want to create colleagues where they can talk and hand off work. And again, not very complicated, but it does matter. And a lot of people, I'll use OpenClaw since it's the famous one. They have one OpenClaw and it's doing 14,000 things and it's subpar and all of them, and people then end up walking away. Don't use OpenClaw. That's just me using a public example. We have an open source project called Arc, and it's layered similar to how OpenClaw is, where it has an LLM layer, the agentic run layer. It has a agent layer and then a team layer for orchestrating. And so we've been playing with that a lot. We have a private one, and then when something works, push to the public one. But it's mapped to what's it, NIST 853. It's mapped to all the OAuth threat vectors for the LLMs and for the agentic work. It mitigates wherever possible, has automated PII built in before it ever goes to the model. You can connect spacey models to it so that you can custom build it. You can write your own NLP. So that's what we use, and it gives us kind of a lockdown in every single layer with there's a federal config file you can start with, an enterprise or a personal. That's what we have fun with, and we're building a lot of the stuff you see came from us building Arc, using it, and figuring out what worked and what didn't. Okay, that was a lot there. Questions? Dive in anywhere? Got a whiteboard, so I'm ready to dive in. So this is the harness. These are the things that work that you'll see more and more. And again, think of a lot of these as either like software architecture or an actual tool somewhere. So the first thing is self-building tools. How can it make itself better? Well, that's really just giving it tools to read, write, edit, execute, and then some skills on what to build, what to write, what to edit. And so there's examples, and it really just comes up with creative thinking, reading a lot of academic papers. One of the ones that we've done is, I'll show you this. This is really useful for basically any agent or anything you run. Is you write, we have this thing called a policy. Sorry, Steve. And it's literally a markdown file with bullets, so don't think too crazy here. We've got this policy doc, and it adds like we say P1, but it's just a bullet, writes in something. I'll tell you what that means in a second. Writes in something to make it act better. And then you've got your LLM call, and you've got whatever the user is putting in. And it basically, before it puts it in the LLM, it combines this markdown file with whatever the user said, and then it puts it to the LLM. You get your output. When you get your output, whatever that answer is, or tool calling or suggestions, we have a small LLM here that is tuned, LM2, very small, that is tuned to look at this, what was the input, what was the output, what could have made it better, and then it writes up here and adds either a new bullet, or deletes a bullet, or edits a bullet, and there's a triplet at the end, a score. How many times is this going to run? Was it helpful or not helpful? If it's helpful, it goes up 1 point. If it's not helpful, it goes down 2 points. When it goes down to 2, it gets crossed off. When it goes up to 10, it stays. They get reordered. So there's some minor things on adjusting the context. But every time anything runs, it's trying to get better at whatever we ask it to do. So you can see why if you're trying to have it do 22 different things, this is going to be a mix of like a mess that's not helping it do any one thing better. But if you have it just trying to write better purchase orders or whatever, now it's going to get really good at understanding your timing, why you make certain vendor decisions, and all that gets built into the policy. So none of this is hard. This is literally a small LLM, read, write, and then making sure that when you put in your system prompt, you're combining your policy doc with your user before it hits the actual LLM layer. All that can be done in an hour or two from scratch. So a lot of what is important for these LLMs is not this complexity, it's just understanding how to put it together. And so that's what I kind of want to give you some ideas on today to go play with, whether it's your personal models or thinking about it at work. So self-building tools, again, policy is one, there's brain, it's another one. There's a lot of methodologies you can use. You can do recursive context manipulation. Again, this can get really complex, probably not the place for it today, but having to dive in offline on different ways to build these things so they can self-build. They can also give themselves tools pretty basically by just saying, hey, I'd like you to go access the internet, create a browser base, and let me know what else you need. It has enough context where it can go look that up, it can go figure it out, it can write the tool, and now it's got it, it writes a script, and then it edits its own config knowing that it's there. So that is a huge thing, being able to just explain things and have it write it. That can go off the rails too, as you can imagine. This is usually where the security breaches happen, when it writes its own tool to do something. Some of the models I do believe are inherently evil, from other countries. There's stories of them all of a sudden deciding to start, funneling data off and sending it somewhere. So, but I also believe that they have bad outcomes because some of the models do the fastest way to get somewhere. And if you say, I want you to do this, and it looks at it and says, oh, reasonably, if I change the config and give myself access to this, I can just backdoor it and get it done. I don't think it's trying to be evil in that case. I think it's literally solving the problem the best way possible, and we didn't give it the security, the guardrails. So one of the things, this doesn't solve that problem, but it solves a lot of those problems that we do, is every tool we give it, we stack it with a skill of how to properly use it. And so this gets really meta, but you've got a tool that you write, which is literally just a Python script. I'm saying this for those that got to ditch later, just some things to look into. You got a Python script, but every time you write it, you also, our tool has like at the bottom of the Python script, it has like some text that it allows it to read, basically an XML, and it's like the tool name, the description, when to call it, read or write only, whatever it is, that's like the metadata of the tool. And so every time our LLM decides to call the tool in the agentic loop, it basically gets all of our tools wrapped in this. So you'll have tool 1, tool 2, and it's all in XML list. And so now you can see everything that it has access to every time. One of the things that it has is, what skills do I have? And so we'll give it how to actually execute and use it correctly. And so now we've got a tool associated with a skill. The LLM gets both through progressive disclosure, which we'll get into this afternoon, and can basically operate better and better. So it can write its own tool. It knows how to write a tool because we have this meta part. We have a skill that tells it, here's all the tool rules. It needs to have description, call, read, skills. You need to write a skill. There's a tool writing one, and that calls a skill writing one. These are baked into the agent itself. So now when we say, make a better web browser, make it so that I can get to the JSON and be able to, direct enter input, it's going to build a tool using our tool skill, going to build the sub skills using our skill, and then it'll come out with a new tool that will get loaded into the XML and then put over into the agentic loop. Again, we're going to go more into this afternoon with actual Jupyter notebooks, but wanted to just kind of show you how to think about having this stuff build itself. Is you have meta, and then you've got the actual, and then you just make sure your loop can grab it. Anybody got that far with building what they're building and thinking along these lines yet?
Because you're talking.
So yeah, but again, none of it's complex. It's 2 markdown files, the ability to write a Python script, and then make sure that Python script has metadata that can be exported and pulled in on an agentic loop. It's probably as technical as we'll get this morning, but that is one of the biggest things that happened with this is its ability to realize it needs something, being able to write it. That's how it writes it, and that's how we keep it controlled, is through the skills that build the skills and tools. The second one was memory. So let's go through it this way. These are examples of some of the ones that it's written itself. So what we do a lot of work in commercial too, manufacturing, supply chain, and so like building its own vendor risk score based on how we were looking at vendors and realized it could just write a script to do it. One of the skills we have that is loaded in every agent is push everything that's possible to determinism so that we're not wasting tokens and we're not getting variable outcome, especially when we're trying to store margin drift, normalizing skews. These are all types of tools that our agents have written for themselves so that they can better operate more consistently. The memory, oh, is this what you were talking about, where you're trying to do at home, or like memory retrieval? So there's a ton of academic papers on this. They're all over the board. One of our demos is basically testing like 5 different memories, ingesting data, and then seeing when we request it, like what retrieves what. The way to do this, like a couple of months ago even, was RAG. Y'all know what RAG is? It's searching. It was glorified search. Like we solved search with index, and then I also went back to these embeddings. The way it works is it looks for similar, it basically embeds whatever your request is, and then looks for similar embeddings in a database. The way that it does it is cosine similarity, and you would basically get 5 things that look exactly like what you asked, which means you don't get the full picture, and it tends to either, it has exactly your answer, or it hallucinates something crazy. Like there's no in between. It doesn't say, I don't know. It just, you ask it one thing, and the 5 closest things it has aren't even close, but mathematically they exist. So you get some that doesn't make any sense, and it tries to, it's an LM, force it to fit your question, and that's where the hallucination comes. You get an answer that isn't an answer, being forced to respond to your answer. But reasoning models, we figured out they're really, really good at command line interface. And so what you've seen a lot, and this is the reason for it, is memory has gone largely to markdown files. Has anybody played enough to realize that everything's a markdown file now? The reason is because the CLI power of a reasoning model is like 100x better than whatever retrieval tools we can build, VM25, rank sorting, all that stuff. It's us trying to hack it. Turns out just telling it to search a bunch of documents is like way better. And there's ways you can improve it. You can add tools to that. Again, we'll get into that some more time. But what we have done for our brain, I'll dive into this a little bit since there was some curiosity here, is we have a taxonomy of what we want stored. So we have like procedural. So we pull from Slack, email, Confluence, I think that's it, through an ingestion. And then what we do is say, we pass through a taxonomy like 17 things. We say, look for episodes, something that has happened. So if I'm talking to BT and I say, Dell's going to help us with an AI roadshow, they're giving us 15. There's an event there. 15 things have been procured for an AI roadshow between me, Brian Trenholm. It'll store that in its episodic area. And then we've got like 17 of these. We've got people and entities. I can show you all a little later. I've got one of our smaller brains here that actually has saved all this stuff. So every time that it hears or sees something about Brian Trenholm, it adds it to his entity file. So now I'm building this file, this FBI file on Trenholm and what he's doing. It's got one on me, it's got one on everybody. So we have entities, we have episodes, we have procedures, how we do things. We have anti-patterns, never do XYZ with Cisco, that gets put on there. And so now we have is this brain, and then our retrieval knows about that taxonomy. So it knows that when we ask something, I'm going to check episodic and I'm going to check procedural to see how to do this and what happened previously related to this. And then we let the CLI take over with Markdown. So basically a semi-decent retrieval, a taxonomy of how everything's stored, in a skill that describes that. And then what you have is you can do it 2 ways. You have ingestion, which is basically every night we take all the data that we've created, whatever emails we're following, Slack, we ingest it and put it in the right spot. That's like a nighttime thing. The other way is as you're talking to agents, gets to the end of today a little bit. As you talk to agents, we say work through them because you're using their tools. They're doing it for you. It's taking all of that and constantly running it through a kind of a small LLM evaluator, saying, is there an episode here? Is there an entity here? It's constantly updating our Markdown repository. And we do use Markdown and embedding. We use both, and then you can hybrid them and rank them. That way you get the best of both worlds. But that is kind of how we build our brain, is this taxonomy. We call it the Atlas, and it's basically all different types of memory that we say. Some of them have to do with like goals of the company that has its own thing. All of our goals are there, always being updated and modified. What's cool is when you start doing that, you start to find implicit goals. So maybe not a goal that has been stated, but it's implying it in a lot of the conversations. Like, oh, you're trying to achieve this thing. You're like, no, we're not. It's like, oh, the way that we're talking and holding meetings, we are implicitly saying it's what we want and we don't. We got to change our talk, change our meetings, make sure we correct that. So it does pull out these implicit things that almost cause you to double check and realize you're driving somewhere that you don't mean to be driving. That's just been kind of a cool side thing in the way that we build the memory internally. So you got episodic, semantic, procedure, all these things. And then when you get it, the more you use it, which is why we've been using it for like 1.5 years now, because we just realize more and more. The bigger this brain gets, the more it doesn't know what's new and what's old. So now everything gets tagged with like a date so that we can run a decay on it and retrieval, and we can rank them that way. And so we'll get answers like, your rep used to be XYZ at Dell, but 2 months ago it changed to this via, Sam let us know. And so now we'll start to get those kind of decay alerts. It doesn't quite know if it should drop it. We haven't figured out when to drop info. So far we don't. So it's always included in our LLM call. Questions on the brain part. But yeah, that is basically a skill, Paul. That's all we did is everything that we type or ingest goes through the same skill. And the way we build skills is there's usually like 10 to 15 subfiles. So for us, a skill is a folder, not a file. And each taxonomy has its own reference. That has to do with token usage. Otherwise, if you write the whole thing up front, you'll blow up every call. So what we do is we make it so that the top level skill knows, like, here's the 17 things we look for, and here's where to get more information on them. And then when it thinks it found procedural, it'll go to the reference to procedural, markdown, get more. That's that progressive disclosure, only pull in what you need when you need it. And so it'll go get that, and then it'll pull it in. So I can share that with you, and then you can modify it as you want if you want to give it a test. But I can just give our company one to you.
Yeah, I probably don't send it.
Okay. So validation and planning. How many here one prompters, one shotters? Just help me solve this IP problem. Enter. That's most of you. Don't lie. Even I'm doing it at home. I was just laughing with Brad because we teach this and we use it at work. And then we were in the car and he's like, check this. And we just one-shotted it. And I started laughing. I was like, we just got done telling everybody not to one-shot. Here we are in the car, just one-shotting. But one-shotting is when you just ask this question and you want it like everything done right the first time. It's usually low stakes stuff that'll work. When you have an agent that actually has execution capability, no, we're not going to one-shot. There are 3 steps to every proper prompt call. And so again, this afternoon, you'll see this. We have a coding workflow that has 8 steps, 8 full steps before we will do a PR on something. There is a planning. For us, planning is brainstorm, build, deepen, and specify. So we have 4. 4 of the steps are planning. And what it does is it basically makes sure that whatever we're about to do is properly thought through. A lot of times that one shot, you just say, okay, for a quick answer. But when you're building code that you're going to be relying on, you need to think through the dependencies. You need to think through the different database decisions. Is that going to hurt something later? So you can use AI to help with that, but you don't want it writing. You don't want it implementing. You want to be in plan mode. And so we make sure that everything the agent does, it creates a plan first, then it does it, and then it goes and validates it. Validation through deterministic scripts and or quality checklists. Again, markdown file. Don't need to make it complex. So all of our skills, every single skill we use at the company level has how to plan, how to validate. So again, we can share our meta skills for that later. Whoa, and a caveat to this, for running departments that are using AI, what we are noticing is the middle, the execution is where AI is good, right? AI can write code. Where it's not as good as planning and validation. We have found that our work as people, this is like some inside baseball, as CTG, how are we thinking about AI and people and who we hire and what they do is largely around this framework. We want people to be planning, right? Thinking, ideating, strategically thinking about the breakpoints ahead of time. Okay, if this works, this is where it might break. We want planning, and then we want them validating. We don't want AI spitting out emails. We don't want AI just writing code that gets PR'd in, right? We would love to move execution. Can never be 100%. So the more we can move to execution, the more our people can be planners and validators. If you think about how our brains work, how most of us in this room work, that is a higher level use of our intelligence, of our ability to think and reason, planning, and our ability to double check and problem solve. validate. And so what we're saying is at CTG, we want everybody to be able to use more of their brain and not have to go down into monkey mode, which is where we're all copying and pasting and Excel and all that. That's what drains us all, right? That's the day we go home, we're like, today was, I didn't get anything done. All I did was move data around. So if we can get AI to move data, we can do planning and validation, even as our jobs. I think we'll be happier, and I think we'll get more, we say, how do I word it? More brain power per person. So they feel better, we feel better, more gets done. But even on a fractal level, moving this into the agent, we have the agent do the same thing. Like, come up with a plan how you're going to do it. So I can show you some of our PRDs that are created, and then later we code, then they get executed. A workspace. This giving, like, we have what, OneDrive, Dropbox, whatever's used. We have somewhere to store files, to write notes. We've got our Apple Notes. The agent doesn't have that because it has memory, but if something doesn't pass the memory filter, like it's not one of the taxonomy things we said, it's gone. You can store sessions, which we do, but giving your agent a scratch pad where it can write whatever it wants, and literally telling it that, write whatever you want this file, call it working or whatever we call it. And then a place to store files. So if I send, I'll tell you, this entire presentation was made through an agent while I was on a plane a month ago. So I was texting my agent, and it created this because it had a workspace. Otherwise, it would have been all in memory, creating Markdown, asking what to do next. Because I had a workspace, you could do it. I could read it and say, that's not what I'm looking for. Look at this file that I kept saying, look at this file from 2 months ago. This is the concept I want to bring across. Oh, we'll rewrite that part for you. So it had the hands, it had the tools to go do it. It had the workspace to save it, and then it could read it and we could communicate about it. And then it also updated the brain on what I'm actually trying to do here while I'm writing through it. All of that was possible because of the workspace part. So give your agent somewhere to go. More importantly, what we have found is this has become where we're sandboxing. So this is where our security has been. So what we've done, here's the thing, OpenClaw has all their configs inside the workspace. This is one of the major security issues. So the thing it can write anywhere on your computer. Arc has a workspace. It cannot write outside of the workspace, and all configs are outside the workspace. So you lose the capability for it to self-change its configs. We're okay with that. Like, we'll set those. We don't mind manually setting a config file. But that is one of the places where we've been able to basically control security is sandboxing. If you've used OpenShell, anybody heard of OpenShell? Yeah, okay. So that basically, this wraps inside the agent, and then you can use OpenShell to wrap the entire thing up so it can't go outside. And OpenShell is pretty good at locking down. And then this one was huge. We all know what cron is, I assume, right? That's not blowing his mind there. Giving the agent the ability to write its own cron was really powerful. And it's these simple things. That's why I want to bring them up. Like, these are the simple tools that you add to the LLM, and all of a sudden you get something like, hey, remind me next week to email BT. Or hey, every Monday, go pull this report, look for anomalies, and send me an email. It will write that tool, and the reason it can do that is because it can write its own cron and actually go kick itself up and do it. So I get a report every morning from Olivia, who's one of my ARC agents, and she goes and reads a bunch of files that get dumped from things that I did the day before and reminds me what's important and what to work on. It's a stupid little thing, but I am all over the board. As BT knows, I'm kind of involved in a lot of things, and it helps to have a reminder of, like, you said, these are the 5 goals for you in the next 3 months, and these are the to-dos related to those. Do these first and then go off. And so, again, Olivia does that. She can do that because she set her own cron, and I said, send this to me every day at 8. So
That also helps with the utilization of your tokens, right? Most people come in, they want to load everything during business hours. We've all seen Anthropic change their window and their cost of their tokens in the frontier model during business hours. So be more effective at scheduling the tasks throughout the 24 hours locally or on. It's going to help you, even on prem, you don't get that full load during the business hours. Schedule it more effectively. Lots of hardware.
yeah, we use nighttime a lot for the longer ingestion, the longer LLM models, a lot, because you have no concurrent users, so you can just let your long stuff process. Again, especially on-prem, when you've got your own memory cap. They don't let me put in an RTX 6000 at home yet, so I'm still working on GB10. questions on that one? Some simple things that you can attach to the LLM through an agentic run. Does everybody here know what an agentic loop is? Simple concept, but I keep using it. I want to make sure everybody's there. No, okay. So here's the concept. So we got, like I said, when you chat, say 2 years ago, you would put in your user query, and it would basically, the LLM, all of us is a function machine. You put Q in, you get Q plus 1, which is your answer. And then you put Q plus 1 in, and you get Q1 plus 2. It would just keep going around until you had your whole answer. It was just predicting the next token. It was kind of making it up as it went. That's why you could see it drift the longer the response was. Well, with reasoning, what we talked about earlier, we need a different model for that because we're going to be doing things in between. And so it's called React. You guys have seen that? React model. It's basically, here's an LLM. You are no longer going to give me an answer. You are going to tell me what tool to call. It's called reasoning. So you're going to say tool 1. And you're going to keep in the loop this thing that says, what does the user want? What is the end goal? So it's not necessarily what you type in. It's how the LLM processes what your end goal is. So if you say, I want you to set a cron, right? Let's say I want you to remind me tomorrow at 8. End goal is reminder at 8. So what's the run this reasoning? It says, what's the first thing I got to do? Well, I have to write a cron. So it goes through, instead of Q plus 1, you're gonna see it in that thing. It's gonna say writing, or it might even be like looking where's cron stored. Like I'm gonna go look for where your cron, estimating config, like whatever the first step is. And then it goes back to the LLM and it says, then we do the goal. It's like, no, there's no cron yet. Great. So then it goes back to, so what's the next steps? Okay, we found where the cron is. Then you're going to say writing, and then it goes back and it says, can we do the goal yet? Not sure, maybe. Part of this is that we have to validate it. So we'll go through and say testing. And it just keeps, the agentic loop is basically a tool call or reasoning happening over and over. And each time it's being measured to, did we finish what the end goal that we think is? That is why when you type into Claude nowadays, or Claude code, you see those little over arrows, and it's like, tells you what it's doing. That's one loop, and it's going to run that agentic loop. That's why you keep seeing all the stuff that it does, and then it gives you an answer later. This is what's happening. It's comparing it to an end goal, realizing it hasn't completed it yet, and saying, what is just the next step? What is that plus 1 step that I can go through? So with that happening, this is where we can insert. This is why we can do all the cool stuff with agents, because we don't have to give it 14,000 skills in all of our memory. It can run just what it needs on each loop. So in each loop, you're basically saying, I just want you to grab this skill. Now I just want you to access this tool. And so we can build almost these little self-contained actions that it can take. And then its reasoning is which action to take. And so it's got this complex network of skills combined with tools that it can mix and match as it sees fit. So really all we need to do is feed it an end goal and a list of all the tools and all the skills that it can access. So that kind of XML. So we're getting closer and closer to how we turn an LLM into a coworker. Some more things. Once we got this up and running, we said, you know, whoa, this thing can write its files, searching things. It started going other places. We had to slow it down. So this was some of the other stuff we started building and working on. First of all, orchestration. That's the plan, act, serve. But how do we get that to work with multiple agents that have different goals, different policies? We started saying, hey, you know what? Again, a lot of this is going to be a no-brainer to you all. But the same organizational things that you do in your department work for agents. Don't give one agent 14 tools. Give this agent one tool and this agent another tool and 2 different skills, right? We're starting to diversify. If you give one agent all the skills and all the tools, it can do anything. But you start to split that up like we do with IT, like we do with finance. Now all of a sudden you've got some checks and balances built in. It doesn't solve all the problems, but these organizational, again, I'm gonna keep saying this because this was our big realization. Most of the issues with agents is organizational, not actually technical.
You use the same amount of tokens that.
What was the question? I'm sorry.
You use the same amount of tokens. It's whatever it is, having one agent.
No, it's slightly more, but it's not exponential because it has to be a handoff usually, and that handoff is writing something. So there is that. There's also you lose what's in memory from the first agent. So the first agent will go find you have it look at like your software. It'll map out your thing, and it'll be in the memory that like, oh, this is what it's doing. This is where it is. On the handoff, it's not going to be able to put that entire memory. They'll put what it's doing, but then that second agent will probably have to go remap code. And so you're getting into like token optimization, which is like a huge thing. And that's why we pushed to deterministic. We've got progressive disclosure. We've got a bunch of, I don't have a lot of it. We have some of that thinking here today that I can share of how we've taken token usage down quite a bit. There's caching, there's all these techniques. There's a chart, and it's not here. It was on Brad gave it inlet. He had it, and it was pretty interesting. But there's chat, which is, I'm not going to make up numbers. So many hundreds of thousands of tokens a week that a user might use. Then there's coding. Coding gets up into the billions when you're coding. And then there's agents, and you're looking at your tens of millions now a week, just with a few agents, and it scales fast. And once you have the agentic framework, you can just duplicate an agent and change all the configs and have another agent, and then you can work them. So like we've got a manufacturing facility, we started with one, and now we're to like 700 million tokens a week. They've got 10 agents running, and it's just calling tools, checking production, doing reports, helping to line feeds, predictive maintenance and analysis. And they keep finding more and more use cases. So now they've got stuff on-prem, like they're not paying for that. They just got something on-prem that's feeding it all. And we just parallel two calls at once, and then everything else can just wait, because latency is not a concern for them. They care about it getting done, but it doesn't be done now. So we chose to let latency go up. All right. Orchestration policies are a huge thing. I use policy for 2 words. It's a little confusing. I'm sorry. There's policies have to do with how we update our context in real time using those bullets. But then we also have policies that define authority. Where can you go? Where can you not go? These are not in the agent, because otherwise the agent will change them. These are externally to the agent with the actual tools that it uses and how the actual software runs. We do use guardrails. I don't trust them. I know it's a really popular term, all the guardrails. A lot of them, like they work 95% of the time, but the whole point of the guardrail is that you need 100. So to me, I don't like to rely on them. We might use them just to limit the amount of external security work we have to do, but we rely on deterministic tools for security. So I'm going to go through this quickly. I think we're getting close to the end here, but what we've got now, we've kind of covered like what to add to the LLM to make it useful, to make it a coworker, still alone. There's no phone, there's no way to communicate. So here was our next big aha on turning these into really useful. These are like the 5 things that we found. Again, if you run a department or a team, this will all make a lot of sense to you. You hire that person, and all of a sudden start asking questions that you haven't thought of in like 4 or 5 years because you haven't. Things are just working and moving, and everybody's got experience. But the first thing is like, how do we communicate? When do you text me? When do you hit me up on Teams? When do you email? Do you even have access to those tools to be able to communicate? So we had to think about, how do our agents communicate? When do they go one-to-one? What format is that? What's the protocol? When do they post publicly so that maybe my procurement agent can see that inventory has a problem and maybe it changes its procurement strategy as a result? So we had to think through how they communicate. Shared knowledge. Ours have 2 brains. Each individual one has a brain it's building. And then there's this higher level one. What do they put in the higher level one versus the individual one? Personally, what we did there is we have an extraction LLM that runs at night on all the individuals and just promotes certain things up to the individual brain based on some criteria that we gave it. So we didn't go very complex there. We didn't think there was a reason to. And it doesn't build for real time. It's kind of for later. And then whenever we ask the agent a question, it has 2 retrieval scripts, one to the company brain and then one to the individual brain. But you need to have that. Execution. How does an agent go do something, and how do other agents know that it's doing it? This is a real issue in multi-agent coordination. Even Claude hasn't really figured it out. What we did is we built like a very simple JSON assignment. It said, when you go to do something, write what you're doing and when you hope to have it done. And if you need something, then assign it to another agent and then the date you need it done. And then our agents are on a pulse, and every hour they just check that task list, and then they run it through their agentic loop. They say, oh, this is the end goal, go do it. If it's not done or you need to wait on a feedback, you should set a cron to come back on and finish it out. So we're mixing and matching now. We've got a task list, we've got the cron, and it kicks on and goes to find out how to do it. Transactions, this is like with our systems of record, basically, could be an ERP, could be a registry of IPs, but like giving it access to that, giving it a full audit trail. So one of the things that we do is we have a full cryptographically signed hashed audit trail of everything that the LLM does with all of the data so that it can't be changed, tamper-proof. We can go back and always look at what the LLM did. But we want to give it access to be able to do some things sometimes. So again, those transactions. And then the work product, it's kind of like the workspace. That's going to be the shared Teams folder, OneDrive folder versus the individual. And so when you give a team all of this that agents can access, now they have all the collaboration suite that they need. I should say all. They have a collaboration suite that allows them to work together. So these were the 5 that we had to build over the last 6 months to get our agents working much better together and to be able to coordinate and try to solve problems. There are some really, really interesting academic papers coming out right now on agent coordination. We've been playing with it a little bit where we don't give it a goal, we just see what they do. Sometimes that falls flat, they all just stop talking and the system crashes. Not literally, but like they don't talk and it stops. Sometimes, and we're trying to figure out what's kicking it off and what's not, they'll start to actually collaborate around a problem, find a solution, divvy up the tasks. It's interesting. We haven't quite figured out the vectors that are causing one and causing the other, but that's what we have to force it to do everything, but there is a way to get them so that they recognize problems and we don't have to like push it with a prompt. And that's what we're trying to figure out. How do we self-find problems and then coordinate the solution? This is one where they invented their own protocol for manufacturing. That's one of those ones where we told them to solve a problem and it did a pretty cool job. It knows all the same way it knows about skills, it knows about agents on the team, and it's found out the agent that could help it that had access to the right information. This is both fun, interesting, and security scary. It's like, oh, you have information I need. Why don't you give it to me? And it basically didn't have to access the tool. It socially engineered with the other agent. We didn't have guardrails to not do that, but it was like, oh, another security threat surface that we got to start thinking about and build in. So this is probably the last really important thing I want to share because this.
Before you move on.
Yeah.
In that scenario, was it logged anywhere on?
Yes. Yep. It was in the audit trail, and that's how we realized it got the information. I wasn't trying to hide it. It was just like, oh, you're the procurement guy. Who's the vendor and whatever. And all of a sudden the inventory guy is saying, don't accept packages from this vendor. We're like, wait, why? How does he even know about that vendor? And then realized they had talked, which kind of good, but all of us can easily see where that can go. That can go really wrong. So organizational layer is where we are playing and experimenting. Not going to say solved or even close, but we're having a lot of fun trying to figure it out. But just, we have like 2 manufacturers that allow us to work with them like $10 to $15 million. We can test a lot of the stuff live with live data in real environments. And it's, low risk. We're not testing this stuff in labs, don't worry. So the last thing, this has totally changed how we built a lot of agents. This is probably about 6 months ago. Identity, and this was an idea from OpenCloud. I'm gonna just be frank. That's where we got this idea. And we were having problems with getting agents to do new scenarios. So if you know the Palantir model, it was basically like they have data, they have logic, they have execution. Execution is them connecting to MES and MRP and all that stuff, whatever you have. Data is obviously they grab all of your data. That's what they love. And then they have this execute or this logic layer, which is basically like a lot of different rule sets and control, right? And you had to know everything that you might want done to properly build that. Going back a couple of years, not today. And so they were basically had experts that were really good at figuring out what all your execution was going to need to be, what are all the rule sets that you have to do, and then building that rule set engine. So one of your decisions is going to be, we have to buy X and Y. We have to populate all of what X could be, all of what Y could be, the different rule sets, and then minimum purchases and all this stuff. They would build all that out, and they were good at it. But now we have this, which totally changes the logic layer. And this is where we've shared this with a number of people, and they are running things that are pretty interesting. We're going to play with this later this afternoon too, using different identities. And the whole idea is this is where we used to be, but now what we can do is replace that rules engine with context and identity. And we can basically call it a decision factory. We're creating decisions now. Before we were mapping decisions, they were already pre-thought of, they were put in the logic engine. We were using data and rule sets to try to predict, to try to choose which path we should take, and then it would execute through the system. Well, now logic, the problem being that we can't make decisions that are pre-programmed. Now we can. We can make them somewhat consistently. And there's a couple of things that come from a correctly created decision. Our identity file is we can create new decisions that have never been encountered before. So as our agent is watching things like supply chain risks, or vendor issues, or it's on the chat talking about how they're not paying on time, even though the decision might not be there, the agent can still make suggestions along a vector congruent with its identity. The other thing I like about it is it's just an example. Is it specifics? We can share it company-wide. It's version control. We can put it in Git. We can start to test it. So the fact that this identity is an actual file with certain groupings that we can test against, we have a golden evaluation set, a lot of stuff that we build. So we can try all these different identities and then throw new things at it and see if it's making the correct decisions, how we want them made. We can adjust, tweak, we can roll back if decisions are getting too aggressive. And so we've got an example later in the Jupyter notebooks where we've got a scenario that we feed it. We give it 2 different profiles and try to see how they make decisions congruent to those profiles. And so we have this with our coding. We have 7 or 8 steps. Each one has a different identity. My security review that does all of our cybersecurity review of all of our code is a much different identity than our brainstorming. I don't want my security guy brainstorming because they'll say, you know what, just don't build it. Don't build anything, right? So I want my brainstorming agent to be looking out, innovative thinking. Do not want my cybersecurity agent to be innovative. I want them pretty dialed in and locking things down. So we do that not by telling it what to do and not by giving it a skill. We do it by this identity file. And our identity files are similar to how you might describe a coworker or a friend. They don't get too specific on what to do. They're very specific on what to think. And so we talk about values. We have values, philosophical beliefs. We have personalities. We use something called culture index. You can use Myers-Briggs, use any framework that the LLM might know about. And you can basically say, like, we want you to be aggressive, urgent, low patience. We basically map out an exact personality pattern, and it largely makes decisions in line with that. So that's kind of this thing back here of like, you can have a conservative buyer, an aggressive buyer. Conservative buyer is going to make a different decision than an aggressive buyer might. And you can lock that in, again, version control it, test it against 400 preset decisions on how you want them to come out, see where it's wrong, go back, tweak the file again. If you have an evaluation set, you can lock the identities in, and then you can basically watch them over time as new decisions need to be made. You can have a decision factory. So now you're not locked by what you pre-thought of. You are a little more less deterministic, but you can, in real time, the whole thing will break if it gets something new that it hasn't seen before. Golden sets, all that's important. The other thing that we do is you can save those decisions, those decision traces. So who made the decision, what was the identity file, you can hash all that together to make sure none of it changes. And then you can start to save those in a ransom. And so now all of a sudden you can start to look back on previous decisions, talk about like self-healing, not quite the same, but self-improving. It can learn from its own 2 ways. One, you can take all the bad decisions out, keep the good decisions in, and then use it as a training set for reasoning, how you can reason on your historical traces. And then 2, you can use it in the brain and just give it a retrieval. Go retrieve past decisions, mostly episodic is what works here. And this brings us to why we really need to be on-prem, why most people are going on-prem. Again, even the kids that are doing this are buying Mac minis. Because what you get, I talked about that already. We'll go back to this. What you end up getting, I skipped forward. Maybe it's not this one. What you're doing is you're building intelligence, right? You're building whatever your department is, your company, whatever it is that you're doing. The more you use this agent, again, I said this at the beginning, but now let's map it to everything we said. It's got memory, it's got tools, it's growing a lot of data. And when I bring that data to Jira or to Confluence, or to an ERP or whatever it is that I'm using, Jira only knows about what's in it. So it's going to use an LLM to like rewrite the title for me so that it makes more sense to the guy who's going to fix it. That's really cool, but I can't actually use the intelligence that I'm building. The way that AI works, the more context it has, the better it can act. When I say AI now, I'm talking about agents with these harnesses. So I need all my intelligence in one spot. First of all, Nowhere allows you to do that. My CRM keeps it in the CRM, my ERP keeps it in the ERP, Jira has their own thing. We're renting silos of intelligence, and then they're building AI on top of it, but it's really a RAG, glorified search and summarization. Where you really get the power is having the intelligence. One, I don't want to give all of that to anybody. And two, so one, I want it on-prem. And then two, I can't, there's nowhere I can even put this if I wanted to. Like I could host it, but now I'm using APIs and my costs could be crazy on the agentic runs. So this whole thing about AI is context greedy. It's trying to build as much context as possible. It's going to grow more and more as we start to build these brains for companies. And the more it knows, the more useful it is. It's also more useful for all of your tools. So like Salesforce is an example where they're changing their entire SaaS to be agent friendly, right? Or have an agent friendly version. I think the ones that are going to be the systems of record that will survive are making them for agents. We're moving to a bring your own agent world, bring your own intelligence world. So the companies I believe that are ahead that are doing well are the ones that are building their own internal agents. They're building their own intelligence. They're working through the agents so that the intelligence builds. And now they can take that to any API, any software. And again, we're still in this shifting mode, but imagine all the smart ones eventually start shifting towards agentic access. Because I think if you don't, we're just going to whip up our own version of Jira or whatever in a weekend with vibe coding. But the smart ones are going to realize that nobody really wants to host Jira. Nobody really wants to rebuild their own system of record. What I'd love is just have my agent go access your well-built system. So I believe this is why we're building all these decisions internally. We're going to be processing agentic token usage. And now we've got this intelligence issue. So this is why I believe everything's really going to on-prem. I don't think the kids will say this, but this is what they start to realize too, is the more that they had it with themselves, the more that they could own all the intelligence and then bring it for what they're doing to SEO or wherever they're trying to play with it. Ahrefs didn't have enough information, but they did, and they could manipulate Ahrefs or Google Analytics, whatever they're doing properly with the full context of the projects, their goals, what they're trying to do, their voice, their branding style. They could bring all of that to a tool rather than trying to get all of these different tools to talk to each other and none of them being full. We talked about this. We use this is like the security part of all of what we talked about because if you have thinking through any of the stuff we talked about, there's a lot of scary threat surfaces here. We can script actions. There's also this is some of the things that we use. We red team the identity a lot, so we have a whole set of agents that red team a lot of what we do. We have 8 review agents that work on the back end of our coding process. That's like the second to last step. And we have our coding identities and all those sub agents that they work. One thing you find is if you properly build your coding structure, you're no longer really vibe coding. You've just moved execution of code writing to agents. The reason a lot of this vibe coding doesn't work is because they're just one-shotting, move this button, get this to work, connect this. If you build a well thought out plan, like our plans are no joke, for each spec that we intro can be up to 20 pages of exact specifics, how to do it. And then we run it through what we call build, which is give a human every architectural decision that needs to be made ahead of time and think through the project. So where does something go? How does it connect? What classes are combined versus separated? How do the classes get combined at runtime? Like all of those are being made by humans, not by Claude just guessing and going through. So by the time it executes, it's pretty dialed. And there's a whole validation stream. So code simplification, refactoring, security review, best practices, modularity. We have a number of them that run. When you do that, you get pretty solid code that gets rid of a lot of the AI slop That's been our, took us about 7 months to build that, but it's pretty helpful. Having evals is huge. Nobody wants to build an evaluation set. They just want the agent up and run it so they can have some fun. But this is a huge part of making it work right, is testing every change to the harness, to your prompts, to your system setup against golden evaluations. This is what I'm going to run later. I'm going to run Ematron. I usually run Ray. I only brought one of them today, but at home I've got 3 connected by the 200 gig connectors. And so I have them split, distributed into using called Ray. And then I serve them with Triton. You can serve them with VLLM. It's a little more complex. I like Triton for Ematron. It's just the NVIDIA stack. It's all available. And then I'm not running OpenShell on this. I'm running on the one at home, but this is kind of how OpenShell works. So Arc is the harness that has its mapped. You can view how it's mapped on GitHub. We walk through it all. And then you can also put it kind of inside the sandbox cage to make sure it doesn't get out. And OpenShell can be opened up, but I think their defaults are pretty good. We don't have to get into Arc. This is how Arc works. I kind of went over this layer before. So the whole point of Arc is, think of it as a open collage type thing, but we started building it beforehand. Arc LLM is just a unified LLM layer with no imports. So a lot of the other ones run something called Pi. Pi imports a lot of code. You have a lot of supply chain risk, like a ton of supply chain risk. The goal here is as little code as possible. I think we have 5,000 left. No, we have more than that. 15,000 lines of code in the whole stack versus 500,000 lines of code. And it's trying to get a lot of the same things, but actually writing them the key. If I coded that, there's modules everywhere. There's no SDKs imported here. This only uses an HTTP import, a direct curl every time, so we can control everything. The goal is simplicity, security, mitigation of OS risk threat surfaces and NIST requirements, and then all the way up. So you've got your LLM layer. This is the run that is running the Arc agentic loop using Arc LLM. Then the agent that is adding all those harness structures to the run. And the team that is combining the agents. We're still building this. It doesn't work very well. So that's kind of how we built it. Is it's separate modular layers so that you can plug and play, use whatever. This afternoon, we're going to be running like Jupyter notebooks and all that. We're going to be running it through Arc LLM, not through like a Pi or whatever else your coders use. And again, this is kind of how it's built. Everything has to be signed, sandbox execution, basic stuff like PII redaction. An I by default is that there's 3 tiers of the configs. The federal is an I by default. You have to open everything up manually. And then every agent has an ID too. So you can see that later. Everything we open up, you'll see agents all have this ID, and that's what they use to sign. Yeah, so to where all of this, I'm running this on a GB10. Again, at home, I've got 3 of them. You can put them together as a unified layer. You can do more than 3, but only 3 is officially supported by NVIDIA. But I mean, you can run to 10 of them. So right now, I've got a switch coming in. I'm gonna try and get up to 8. I have found that 3 is pretty good. I got maybe 10 models on mine. I can switch instantly with 3. That was my big problem this morning, is I only have 1, and the model reload was taking like 2 minutes. So the examples this afternoon were going to be pretty slow. So I basically just preloaded 1 model, Llama, and I'll use that over and over. But again, at home, you can connect them all, and it's really good. This is what I'm waiting on. So this is kind of the next level up. They have this in a desktop form that came out at GTC. When was GTC? Like 3 months ago, February. So they just came out with the GB300 desktop. And so that's going to be a lot more powerful. It's like 700 and something for memory. So you got a lot more upside, basically equivalent to about 3 or 4 of these, or 5 of these combined. So you can do a lot more without hitting memory stacks. The memory stacks occur during the agentic run. So that's why basically it's trying to hold more and more in memory, and you end up getting. So that is what we're building, kind of how we're thinking about it. This is some takeaways for those that are leaving. We run a roadmap with commercial, and we've done it with a few agencies. So this is like a 4-hour thing condensed into 1 slide. But how do you find where you can use AI, right? And a lot of times we're working with our teams. I know I work with teams and they have chat and that's all they know. And they're like, this all looks great. I want this working on whatever I have. How do I help my team bubble up those ideas? And you can help me figure out how they need to be built. So we have these 5 questions. What are you doing every day? Again, these aren't all going to be AI, but these are going to bring up the things that maybe you'll recognize as AI opportunities. What am I doing every single day? Every month, we have like signal phrases. We have a 1-pager from CTG. We can get everybody after this. But it's like every Monday I have to download all these reports and combine them or something. Every day I have to do this. Every week I have to take this, process it, pass it on. I have to look for all the anomalies in the IP log. Whatever it is, you're doing something every day. So do some AI work in there. The other thing is, no, AI does not have to automate the whole thing. A lot of people say, can AI, they think when they say, well, we're going to use AI for this, LLMs for this, we're going to automate the entire thing. No, just take the tedious parts out. Like you can still do work, take the tedious part, like we say, what is the thing that you avoid all week because it has some step that is just mind numbing? Let's just solve that mind numbing part. Prep it for you, use LLMs, whatever, pull, aggregate, process, summarize, whatever it is that needs to be done so that you don't put it off so much. We start with those tedious steps. Internally for us, our tedious step, Nate will cringe when I say this, is getting all the quotes from our vendors in all different formats, and then extracting all the information into a system, like a set format, and then doing all of our work on the quote and then passing it on, right? Quote formatting, you say, is like the tedious step from all of our vendors in all the different formats. Yeah, PDFs, Excel. So we didn't automate quoting, but we did use LLMs to try to streamline and take whatever it was, find the data, not have to build mapping engines, and put it all into a single format so that our sales team could. So what is their repetitive work? Data creation is another one. Where are we creating data every day? If I make a purchase order, I create data. If I am creating data either through action or through just a process happening, logs getting populated, that's creating data. Wherever that's happening, there's probably some opportunities there. Either somebody has to read it, somebody has to send it, there's validation, there's checks, there's financial controls. Something's happening around that data getting created. That probably is an opportunity for others. Humans as middleware. This is that low brain work that we all have to do at some point, and it's horrible. Like you're basically just copying and pasting stuff in complex scenarios. Knowledge transport, system to system transfers. So taking something from the floor, summarizing it for a report for somebody, like just taking that knowledge and moving it around and changing its format. Like again, we've got a lot of demos. We can get live briefings on weather from anywhere in the world instantly. You can get a briefing on a production floor. You can get a briefing on anything instantly when you got all that properly set up. And then expert bottleneck. Your PhDs have to do X, maybe research, but there's all this work before they get to it. Kind of hit this earlier. So they end up spending a lot of time on low-level work to get to their high-level work that only they can do. A lot of times there's a lot of AI use cases there as well. And then what we do, and I'll give all these to you, is we look for these primitives. This is really what LLMs do well. It doesn't do everything well, but it does this. It can parse and extract, semantic understanding, it can generate and compose, it can write, it can reason and infer, it can classify, prioritize, it can match and retrieve, it can emulate a role, it can transform into a map, it has memory and context, and it can plan and compose. And if you build in the harness, it can self-evaluate. And so if you start to think about when they give you the answers to these, you can map them into here. Okay, that's an extraction. Then I'm going to semantically understand it. Then I'm going to generate a summary. And then I have to classify this as a risk or not a risk. And all of a sudden you see these are your different agents, right? Doing each of these primitives, getting better and better, mapping your workflow to the primitives. Just examples of what these might look like. Research acceleration is going to be parse, understand, retrieve, generate, and then emulate a role. We actually have something called Lab Bench, which is in the demo kit later this afternoon, where we can put any question in. It goes to 3 different sites and finds the papers, extracts the information of your question, and then summarizes the current state of academic research on that question. Is that going to change your day? No, it's not. We're not solving, any major problems with that, but we are taking a brain dead thing and helping you just quickly get to it. Links to all the papers right there. It can go right to the site, which makes things easier. procurement, we can have a bunch of these that we built. So the goal is to move AI closer to being a coworker and less as a tool, which means thinking, reasoning, identifying, communicating, and even in some cases executing, or at least giving you what to execute. This is the slide I was looking for earlier. You basically don't want to rent your intelligence. You want to own it. You want your decisions connected to your people, connected to your software, and you decide where to bring it and when and how to use it. And I think this is where we're going. More and more people are building at-home systems. Companies are going back to on-prem to the cloud, either because they start getting the usefulness and then their token bill goes up, or because like with the medical company I was working with, they don't want that information being processed through anywhere. They don't want to find out the rules changed in a year and all of a sudden they have all this stuff over in Anthropic. So they've got a number of systems right up front. Most of these names you know, so CTG Federal is what I'm with. We do all of our AI services work through BlackArc, so that's also us. We're doing a lot of our stuff right now on Dell. So this is the GB10, it's like the same thing as the NVIDIA Spark. And then obviously NVIDIA is powering it. NVIDIA also has an enterprise AI, which is a lot of the software stack that we use to run a lot of this. So just ran you through kind of a lot. Again, a lot of it will make more sense this afternoon when you start going through this and running some code. But any questions on what we covered, how you can use it, where you should start, happy to answer, happy to talk offline, online, whatever you want.